Whether I'm audible?
Hello.
Hello.
Good evening. Good evening.
Yeah.
Good evening. Yeah.
Yeah. Good evening. Mr. Balakrishna Yadav.
Good evening, sir.
Yeah. Good evening, Sheikh Zafar. Can we start? Okay, Sheikh. Can you? You came this time. Last time I think you don't have any issues. So this time you came with
Yes,
some
yes,
issues or?
yes. So, yeah, actually, I'm facing one issue. Also, I have posted the same on the group also regarding the linear thermal expansion of the agitator shaft.
Uh-huh.
So, I have one more query regarding that. Due to the rotation of agitator shaft, will there be any change in thermal expansion, linear thermal expansion, due to the rotation of shaft? Or it will be the same as we calculate from formula using L alpha delta T.
What is your issue? Linear and thermal.
Okay. And yes, I will explain what's the issue and what's the case. First, there is a one reactor, agitated reactor, and there is a gap provided between the bottom impeller, which is an anchor, and the bottom dish as 11 mm. Okay. So I want to check due to the thermal expansion, the shaft going to expand linearly. So that gap which is provided as 11 mm is sufficient for that. So during operation, the shaft, the bottom impeller will not touch the bottom dish. So I just wanted to check how much expansion will going to happen at 350 degrees Celsius, as the design temperature of this particular reactor is 350 degrees Celsius, and the MOC of shaft is SS316L, and the shaft length is around 1.5 meter from the bearing to bottom impeller. So this is my case.
Okay. Anybody want to answer? Okay, Sheikh, actually it's your shaft, there is only 11 mm gap you are telling.
Yes, only 11 mm gap between the bottom anchor and the bottom dish.
Yeah. So who decided that 11 mm?
So it is decided by the process team. So due to the process, they want to maintain as minimum as possible the gap. So initially they have proposed as 10 to 12 mm, and the vendor has provided as 11 mm. So we just want to confirm that because in recent case there is a one reactor which is asteroid cladded. Okay, 15.7 KL capacity, and due to this issue in operation, we face that the bottom anchor is touching the bottom dish due to the thermal expansion. So currently, I am talking about the reactor which is having only 11 mm gap. It is in the design stage only. It is not yet fabricated. So we just want to make sure that the gap which is provided is sufficient. So we just want to check at this stage only.
Yeah, that gap, what you arrived is, as you told that it is a process
Process, yes.
decided, and that
Yes,
impeller which is there at the bottom, which is they want only that 11 mm with that impeller, or they kept that impeller is a bit higher on rather than that.
So they initially proposed at 11 mm, but accordingly we have to propose if due to thermal expansion it is not sufficient, then we have to give the input to the process team that this 11 mm is not sufficient, and we have to increase it from 11 mm to 20 mm. So accordingly, first we have to calculate that thermal expansion, and accordingly we can take the clearance from process.
Yeah, there is two things here. One is that your shaft is coming till 11 mm, the gap between bottom dish and
Yes.
and another is that there is a blades. So how much
Yes,
gap
yes.
between that blades to the bottom dish?
So that blade and bottom dish distance is 11 mm.
So blades also it's completely means till the end of the shaft they are
Till
bringing.
the bottom, yes. The blade is also till it's an anchor type, baby anchor.
Uh-huh. So this thermal expansion and that one again, it is a material property, and that one we have to verify whether that will sufficient or not with this temperature, because also when your shaft is running, it's mixing the fluid which is inside the reactor. That also get heated due to that one also.
Yes.
It's not only the temperature which you are supplying to that one, but also by rotation of that one, that also increases. But 11 mm, as per my experience, that one 11 mm is not sufficient. 11 mm, it's minimal used to keep 50 mm, and also the
50
blades
mm.
will be above that one. So
Okay.
so this 11 mm and that one, I think
Okay.
maybe the some thermal who is expert in that one, they can guide you. I think here anybody thermal experts are there who can guide actually how much, because this elongation and that one again you have to calculate using that delta t and that one.
Yes.
So it means you already done no this delta t using that one calculation.
So actually, the Anshul has guided me in the group to calculate by using the expansion value, which is given in the CSME section 2 part D.
Uh-huh.
Okay.
Okay.
So accordingly, I have calculated it is around for 1.58 to 9 mm around.
Means 9
Thermal
mm, means
expansion.
still
But
within the
yes,
range you are getting.
yes, but I'm not sure it's the correct because we have calculated the linear expansion by using the simple L alpha delta T formula. But due to the rotation of shaft, will there be more thermal expansion? So that's my doubt.
Yeah, yeah. Mine also, with my experience of that one, the minimum used to give 50 mm because this expansion to take care
Okay.
in that one. Also, you
Okay.
have to check with the vendor which you giving this order, no? So tell them that
Yes,
this
yes.
shaft should not be touched in any condition, even in operation in that one. So if they
Oh,
agrees, and then again you have to ask because they are the more experts because they are the
yes, yes.
manufacturers in that one.
Yes, this is like a proprietary item, agitator design.
Uh-huh. Okay.
So,
So it
uh,
so you can means my advice is minimum you have to keep 50 mm, but in
okay.
calculation and that one, if the process really it's they require at minimum of 10 mm only, so maybe difficult because why they want minimum at only 10 mm, because bottom air is any means it's a solid fluid is there which is.
Actually, this reactor will be installed for the pilot plants. So this reactor is actually for the experimental basis. So they want to maintain it as minimum as possible. So they can the process requirement like
Mhm.
it's not for the specific one process. It's for the pilot plant, which is for the only the experimental purpose. So
Okay.
it will be as good as if we keep the minimum gap to the reaction will be good, like
Okay.
something like that.
Kuldeep, you want to say something? You raised hand.
Yeah, sir.
Yeah.
Good evening, sir.
Yeah, good evening, good evening. Tell me.
Sir, my question is that you have an experience for the 620 API 620 tank.
Actually,
Yes, sir.
Kuldeep, we are discussing one topic that is a reactor. So can we
Okay, okay,
finish that one and we'll come to you?
okay.
Do you have experience in reactor design, anything?
No, sir, no, sir.
Okay. I think in this group, I think Anshul, you want to add something because you answered in group something with Sheikh.
Actually, thermal expansion wise, whatever that you are getting after the calculation, it will be fixed. Other than that,
Okay.
the one you are talking about, the agitator movement, that would be mechanical pull. That you have
Yes.
to check with your agitator supplier that how much
Okay.
stretch or elongation would be there because of the mechanical force. Because thermal will be fixed.
Thermal is fixed, but again, when the shaft is rotating, no, on that time also it's
Yeah, that's
again,
why
yeah.
mechanical pull is a different thing. Based on
Yes.
that,
Shaft also
Yes,
get
there will be
heated.
the poles at the bottom due to the impeller at the bottom.
yes.
So due to this rotation also that because if the fluid is very much solid state, then it get heated to mix that one. So due to that one also this shaft get heated when your blades and that get heated.
Thermal expansion is a material property. It won't change because of the force, but it will be added on top of the elongation that you get from the force generated by your agitator movement. So whatever you are getting from the code, thermal expansion, that you need to add on top of the elongated elongation from the force, if you are getting any.
Okay.
Okay, so you got your answer?
Yes, I got the answer. Also, I would like to ask that as per the industrial practice, what they kept the distance between, what they kept generally in general practice, the gap between the bottom impeller and the bottom dish.
That I
Is
said
there
it's
any criteria or something is any general practice?
yeah, that I said it's minimum we
Just
used to
like
keep
50
yeah
mm.
50
Like,
mm. So that is normally normal we used to keep because that shaft also to hold some arrangement need to be provided at the bottom. That bottom
yes.
to weld that bottom and that one that arrangement it's required minimum 50 mm because normally weld to weld gap we used to give 50 mm. No? Like that this there also we used to give 50 mm.
Oh, thank you, sir.
Okay, welcome. Rakesh Singhu.
Sir, can you please explain about the ligament efficiency, sir?
Yeah, can you you are coming first time, no, Rakesh?
Yeah, sir.
Can you please introduce yourself to the group, please?
So myself, Rakesh, sir.
Yeah.
I'm working as design engineer in Hyderabad
Uh-huh.
from last 1.5 year.
Okay. So total you how many years experience you have?
1.5 years, sir.
Okay, okay. So recently you joined. This is your first company, right?
Yeah, sir.
Okay. You are working as a static equipment design engineer, right?
Yes, sir. Strategy.
Okay. You want to know ligament efficiency. Okay. So anybody want to answer?
Yes, actually, ligament efficiency is when you have multiple holes of the same dia at a interval of pitch. Yeah, when you have the multiple holes of same dia at a certain pitch and interval, then you can calculate the joint efficiency based on that, and you don't have to calculate reinforcement. So it's nothing, just pitch minus diameter divided by pitch. You will get the joint efficiency that you have to use for your joints.
Okay. Rakesh, where you are getting this
Is it
issue?
applicable for reinforcement pads?
Yeah. Reinforcement pad, you don't have to provide a reinforcement pad if you are using the joint efficiency as ligament joint efficiency.
Okay.
And
Anshu,
generally,
yeah.
ligament joint efficiency is used for smaller diameter holes only.
Okay. Rakesh, where you are getting this issue? Yours? Your voice is breaking.
Hello.
Yeah, yeah. You can tell.
Got a problem in steam drum, sir.
In?
The steam drum. Drum.
Okay, steam drum.
Drum.
Okay,
Steam
okay.
drum.
Okay,
Okay.
Rakesh, that steam drum ligament efficiency is a very common phenomenon. Okay, so you have to calculate your thickness, the number of tubes are there, longitudinal and circumferential. So you have to calculate that one. So the ligament efficiency you calculate to make sure the thickness of the drum is correct. Okay, sufficient. So that is the intention. So actually your question is it technical or why you
Yes,
are
I-
asking that?
Sir, because of in steam drum the risers are in circular, sir.
No, but it's there in the formula. In IBR also it was there. In ASME also it is there. In section 1 it is there. So why you are asking this question? For the knowledge or for what?
No, okay, not for knowledge, sir.
So
So,
ligament efficiency, yeah, for the knowledge, the basic idea is to calculate the thickness. Okay, so your thickness should be sufficient or not to know. So for that formula is given in ASME section 1. The formula also given in IBR. How to calculate the ligament efficiency as I think Anshul said that. Okay. So it is different for different sizes of tubes. Sometimes the size of tubes pitch are different. So there are circumferential pitch is different and then longitudinal pitch is different. So you will get different efficiency. So you will get the lower efficiency and then you will calculate the thickness. So that is the main idea. But this, the formula is there. So I think there is no worry on that.
so Rakesh, you are not getting that formula, or you don't know that formula? How?
Here the problem is our senior said that we are using nozzles in self-reinforcement. Our senior said that in self-reinforcement we didn't use like ligament efficiency. We cannot calculate. It's okay to manage with self-reinforcement. They said that.
You cannot decide on your behalf or on your senior behalf. You have to go with the code. What code are saying? You have to check. Because that's why the codes are made, right?
Yeah, sir.
You can
Hello?
show this. Yeah, Anshu, tell me.
Yeah, just a minute. Huh?
Yeah.
The ligament efficiency, you have to use that efficiency for shell where your holes are also, not just for the nozzle.
Okay.
I mean, you can have self-reinforced nozzle, but you are actually having the holes in the shell, multiple holes.
Yeah.
So you have to check. And generally, there is a clause in UG 37 also that for UG nozzle falling in the criteria of UG 53, you don't have to calculate reinforcement. You just have to use the joint efficiency of ligament joint efficiency.
No, Anshul, just I want to correct you. This is section 1. So section 1, the process a bit different than section 8. Okay, just to make a correction to you. Because he is talking about steam drum. That's why I am telling this is section 1. So section 1 exactly is not matching with section 8.
Section 1, it's a boilers and that one, right? 5
Yeah,
liters.
it's
5 liters. Okay. So, Rakesh, you got your answer? This whatever the codes given, just show to your seniors so they might be aware. So as they said, it's not calculated, so just show them this in code it is given. So okay, you got your
Thank
answer. Okay. Mr. Prakash Rao, you are coming first time?
No. This is second time.
Okay.
Last week I was joined.
Okay. So you have any issues? Anything?
At present, not having.
Okay. You want something?
Yeah, I just wanted to ask, what is exactly the leaf seal?
Leaf seal.
Leaf seal, LEAF, the one that is mentioned in the baffle design of Tema.
Anybody want to answer? Atul Sharma. He used to do many heat exchangers and everything. You want to answer, Atul Sharma?
No, sir. We did not face it.
Okay, you didn't find. Okay. This is a leaf seal means it's just a sealing that baffles and that one whatever the gap it comes there. So that it seals means as per my knowledge in that one. But I also not use.
Sir,
Yeah.
so it is like a longitudinal strip. We did not use, but I see it. I have some snap also. I will selling on Monday. It is like a longitudinal strip, which baffle fixed in this strip. Longitudinal strip is that.
Anshul, you got idea?
Okay, yeah, just share the snap with me. And did you get your answer regarding the question you asked in the group? Bypass sealing question.
Yeah, bypass sealing. I got it.
Can you just explain?
Yeah. What is the issue, Atul? Yeah.
The issue was we arrange sealing strips anywhere. As per our knowledge, we think sealing we can provide it anywhere. But as per thermal requirement, we have to provide sealing as per not violate C stream, D stream, E stream like. Then sir, we have to provide sealing. If a baffle cut is vertical, we have to provide vertical sealing strip. If baffle cut is horizontal, we have to provide horizontal sealing strip. This is our first thumb rule. Now we have created as per some technical advisor also. And second one is we have to provide it sealing with overlapping area of the both baffles.
So,
and it must be maximum 75 mm to the edge.
Okay.
Gap should be maximum 75 mm from the edge.
Yeah, maximum 75 mm from the edge, and for vertical and horizontal for horizontal.
Baffle cut edge.
Yeah, baffle cut edge.
Okay. So this is a similar to that what you just Anshul, you said it's a leaf seal. It's or something different.
No, actually.
No, Atul, I'm asking to Atul. Yeah, Atul, is it similar?
Leaf baffle is like sir. We use EIL standard for longitudinal baffle, and then we use simplate type.
Leaf baffles. Anshul, you are asking leaf baffles or leaf seals? He is asking leaf seals.
I know he is asking for leaf baffle, but sir, we can assume a geometry like sim, and its leaf baffle have a strip. Baffle conducted with a strip and located like a longitudinal baffle. I will say the snap on Monday.
Okay, if you get snap, it's well and good. Okay, we'll understand better because we didn't use much in that one. So anybody used this helical baffles and that one? Heat exchangers? I think no.
I want to.
Yeah, Sheikh.
I want to add. I think they are talking regarding the sealing strips, which is used as a longitudinal strip to reduce the clearance, so that the heat transfer. It's like a sealing arrangement, so there is a clearance between the tubes and baffle.
Tubes and baffles. It is
Provi- yes. It is provided to minimize the dead zone between shell and tube, I think.
shell and tube. Tubes are means end tube. You want to say the
Yes. At the end tubes, it is a longitudinal sealing strips to avoid the dead zone, so the heat transfer can be effective.
The flow
I think.
fluid will re-back in the between the tube.
Yes. The flow will be reback to the tube.
Rawat, you got answer? Yeah, okay. So maybe on Monday he is sharing some more snaps, so you'll get more clarity on that one.
Sure.
Okay, any more points you have? Anshul.
Nothing from my side.
Balakrishna, you want to have any questions?
I want to share something. We have supplied a BXM type heat exchanger 6 months ago to the client, and from 6 months to now it is under preservation from nitrogen purging.
Okay.
And now it is designing and fabrication is in our and it is X type cross flow type.
Okay.
And we provided a full support plate, no any cut. And now raising query to us because we are vendor.
Okay.
Why did you not provide it any baffle cut? Because without baffle cut it is useless. And in the thermal data sheet, TKI said us you don't need to provide any baffle cut because we have put in revision 0 baffle cut. And they commented okay, we don't require and we do not have any mention in our data sheet. You have to provide it, and now denied to accept it. But we have received our payment 6 months ago, and now.
So it's not your okay. Anybody want to answer? It's not your.
What was the question? Baffle cut means what? What was the cut?
There is no baffle cut, and baffle is full support type.
It's a light plate they added.
Due to this, cell side fluid cannot move one compartment to another compartment.
Yeah, that's again useless.
Baffle means you mean to say sliding cut.
No. The open window, any baffle cut.
They provided circular plate.
The last baffle. You mean to say the last?
Yeah.
You have not provided the open window.
Yeah, we provided in revision 0 as per our general awareness shell side fluid will flow smoothly. Not even mention in our thermal data sheet why you are providing.
But it is a process requirement, right? The cut, the dimension also, the cut dimension also.
Yes. Yeah, it is process requirement, but in the thermal and PDF did not any mention. We generally provided in revision 0, but they remove it in revision 1.
Okay.
And now TK was raising you was right, but as per our process engineer, we can't now do anything. Let's do 50% you pay, 50% our pay. Let's make a new exchanger.
No, but
now you cannot cut it.
No, we can cut it because it is not a used stamp. We can cut it. We have a solution, but we can't. We will not face any financial issues. We want 100% payment because it is not our fault, na.
Okay. That is, I mean to say, somehow it is a commercial matter also. No, I mean to say now at site you can cut, right? Or not?
And hydrotest is okay in our shop and site also, and there is no issue.
No, for this type of situation or scenario, you have to go to site and you have to create a ASME situation. I mean to say, now ASME inspector will come again. They will check that will be like shop as well as site hydro test. You will make a shop at site now to make that happen. I mean to say in normal cases, because now it is like again you have to cut, right, to take it out, and then you have to again weld. So it is like something you are making a shop to the site.
Yeah, we said we can do hydro, but it is chargeable commercial things we are writing because we did not do any mistake na. Because warn us to remove it. We forwarded it version 0.
No, I understand that point, but the mistake, whose mistake, that is a different point. But if you just think about the end user perspective, end user is going to use it.
And warning.
I know, but that is anyway. That's some commercial implication also. For your case, also it will be very cost. I mean to say, if you go to site, ASME involvement, lots of things are there. You cannot just simply do that.
No, we offer them to how much cost? It costs us 17 lakh only. It's a small equipment. The we said we will cut it out and we will provide you as it is, not as a new exchange, but we will take 5 lakh. And Tika has also denied that we will not pay, you will not provide us new exchange while we are paying. Because we have a solution also. We can cut down the large.
Okay, Atul, I think that is whatever the issue means. It's not from your side. Whatever they said means document they approved and you prepared that equipment.
Yeah, documents.
Yeah, you prepared and you submitted to them. And once it's gone to end user, as Kaushik said that the end user not able to use that one, whatever you done. But as Kaushik said that if somebody goes to site, just the Baffles cutting are not much work. I think it's just you have to remove from inside and open the bolts and you will remove outside and you cut.
No, it's a fixed type, na. It is fixed type and seal welded. It is a seal welded.
Okay, then again you have to complete vessel. You have to cut and that. Rather than that one, you can prepare new vessel.
We can do one more thing. We mark the baffle. Where the baffle will be located in the cell side and cut the cell. And remove and cut the baffle and re-weld nozzle with insert plate.
No, that every place the cutting buffel and that shell, I think it's not advisable.
No, we marked up in CAD. It is acceptable. We can do it.
Okay, but that also one thing. But again, who will do means it's not because it's not your mistake. So you have to tell them
we are waiting for the price simplification just.
Yeah. You have to tell them that because it's not our mistake. So it's means the mid person means who contractor. It's your mistake.
Yeah.
So you tell me, we will do that one. We are not denying. We are not denying to not do. But additional charges or price, whatever will be, you have to pay. We will send our maybe site person or will do work. And also, as Kaushik said,
we have submitted our commercial offer also them.
So if they agree, then you have to take care. Otherwise, you said that it's not means it's not from our mistakes or something.
Because the party also involved.
Okay, so they also approved with this one because whatever the drawings or documents they say this is document that one they're not think by logically means end user how it will becomes and that one. So that is the means first year revision you commented, you are saying that you commented, you already said that it's already informed them it's to be cut, but still
we all informed that they said our process did not want any cut.
So it's their mistake then because you can show that because we tried to inform you, but still you want to same mistaken products or job. So we done that like that. You can say that. You can show them the whatever you already informed them in that document. On your side, it's a safer side. You are not
right now we are safer side.
Yeah, you are not. It's your not mistake. Your contractor will take care. Okay. Any other point? Atul sir, do you have any other point?
No, sir. Right now, I don't have any.
Okay. So, any other points anybody want to discuss? Any open points?
Today, I was modeling a vertical heat exchanger, and when I mark up a nozzle in top bottom channel, there is an error. There is a new error coming in output report that your nozzle location reinforcement area is incorrect.
Location area is coming incorrect. Do you have any screenshot or something, or did you share?
Yeah, I didn't take any screenshot.
Anybody want to answer? Yeah. Or did anybody face this type of issue?
And same time I noticed my node number also not showing properly. I think it's a software problem.
Okay, node number not showing properly. Your located nozzle not maybe the software problem.
Yeah.
Because we didn't get location, we get that intersection of nozzle. Each other, it's intersecting.
Yeah.
So
Yeah.
you have to.
If my nozzle is like a 6 inches,
Mhm.
and if I select a render diameter limit,
Mhm.
so that diameter limit we have to require channel section more.
I didn't get what actually.
If channel length is 500 mm,
Mhm. Okay.
and it is not under diameter limit of nozzle, so we have to increase channel length.
Yeah, anybody want to answer? Yeah, if it is not fitting in your limit, then you have to increase the channel length. But if you again the channel length, if you increase, then again the fluid flow and that one you have to check with your process. So whether it will be okay or not.
Okay, got it.
Okay. Any other?
No.
Okay, then if any open points or anything, any topics anybody want to discuss, we can discuss, or you want to close, or we'll close our session. Okay, I think no open points are there, or no topics to discuss. Okay, can we wind up?
Sure.
Okay then.
Yeah.
Yeah. Okay then. Good night.
Good night.
Bye.
Okay, good night. Thank you.
Good night. Bye.
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 Good night.